Welcome to the final installment of our series on mineral oil contamination in food. In the previous videos, we discussed the importance of MOSH and MOAH and highlighted the challenges of detecting them. Today, we'll take you step by step through the laboratory process, from handling complex food samples to obtaining measurable MOSH-MOAH results, and show how automation transforms each stage. MOSH-MOAH aren't single chemicals. They're broad families of hydrocarbons, potentially thousands of molecules per sample. And food matrices vary wildly. Dry and oil-depleted like packaging or cereals. High-fat foods like oils and spreads. Wet and mixed matrices like tuna in sunflower oil. So the goal isn't finding one molecule, it's isolating fractions and measuring them as characteristic humps on a GC-FID chromatogram. When utilizing CHRONECT's MOAH Workstation, liquid-liquid extraction and saponification are seamlessly combined into a single, continuous step. This integration makes the workflow faster and more efficient than the traditional ISO method. Although ISO procedures describe these as separate steps, saponification can safely be applied to all sample types, including those with encapsulated or low-fat content. This step does more than just remove fats. It serves as a powerful cleanup process by breaking down triglycerides and related esters, which helps release and isolate any mineral oil residues trapped within the sample. Since saponification does not chemically degrade the compounds, we use it consistently throughout our workflow to achieve cleaner extracts and more reliable chromatograms. Some natural hydrocarbons can interfere with MOSH analysis, particularly odd-numbered linear alkanes found in vegetable oils like sunflower oil or rapeseed oil. We eliminate these interferences using activated alumina, which traps natural N-alkanes while allowing branched and cyclic mineral hydrocarbons to pass through. For the MOAH fraction, natural unsaturated compounds like squalene and sterols can interfere. So we apply epoxidation. Performic acid reacts with double bonds, which then increases polarity, allowing for natural unsaturates to get trapped in HPLC, which then allows for aromatic hydrocarbons to then continue to the GC-FID for analysis. Traditionally, MOSH-MOAH testing requires multiple chemical steps, the handling of hazardous reagents, strict timing and temperature controls, numerous cleanup and transfer stages, and advanced technical expertise. Because of these challenges, more labs are turning to automation. Further, our specialized software helps streamline the analysis by identifying broad chromatographic humps, removing sharp peaks, quantifying fractions based on retention range, calculating aromatic content, and generating reports and exporting data directly to LIMS. This approach ensures precision, consistency, and audit-ready results with less than 3 minutes of manual work per sample. Mineral oil contamination presents significant challenges, chemically, operationally, and for public health. However, with CHRONECT's MOSH-MOAH Workstation, you get validated workflows with advanced automation that make these challenges become manageable, repeatable, and fully compliant. Your food safety testing deserves precision. We're here to help you achieve it. To schedule a demo, connect with our technical experts.